So look at the wall across the room for now, right now. Or, maybe the coffee cup sitting right there on your desk.
Yeah.
You probably think you're seeing those things exactly as they are, like right in this exact millisecond. But you aren't. You are actually looking into the past.
Which is, I mean, it's wild to really internalize.
Right. And if you're a bit of a science nerd, you know this is a classic fact when we look at the night sky. You see a distant star, you're just seeing the light that left it millions of years ago.
Exactly.
But today on the deep dive, we are going to look at a pretty radical physics theory that argues you are experiencing that exact same time delay with, well, everything in your immediate reality.
It really is a profound shift in perspective. We're so incredibly accustomed to thinking of the universe as this singular event that is just sort of, happening all at once everywhere.
Yeah.
The idea that your own living room is fractured into these different micro moments of the past is, well, it's tough for the human brain to accept.
It totally bends the mind. And to guide us through this today, we're pulling from this highly eccentric, deeply fascinating physics blog.
It's a really unique source.
It is. We're looking at a multi-part draft series that culminates in an entry titled Draft, Mr. Einstein Slacking Off 147.5 Atoms.
Quite the title.
Right. And because this text is, wonderfully dense and full of wild historical metaphors, we're using a version that's been heavily annotated with a breakdown from an AI studio analysis, just to help us decode it all.
Which is incredibly helpful because the author of this text is attempting something massive here.
Oh, yeah.
They're directly challenging the foundational assumptions of classical physics. I mean, taking on Albert Einstein, Hendrik Lorentz, and the whole concept of special relativity.
Okay, so let's get into it, because the core of this author's argument is that classic physics got the geometry of the universe fundamentally wrong.
Right, by relying on what they call a God's eye view.
Exactly. And they propose basically throwing out the old maps and rewriting space as a time sphere, which is based entirely on information lag. So our mission today is to extract the absolute best aha moments from this wildly imaginative text so you can look at your own reality in a completely different way.
And to set the mood for this, I want you to picture the backdrop behind me changing. Like imagine a traditional flat virtual chalkboard with a standard math grid on it.
Okay.
Now slowly, that flat grid starts curving. It wraps around us, shifting until it becomes this fully three-dimensional, immersive star map.
Oh, I love that visual.
Because while we're going to tackle some intense theoretical physics today, we really want to keep our focus squarely on the deeply intuitive, relatable reality that's at the center of this author's argument.
Yeah, and that flat chalkboard is actually the perfect place to start because the author's very first target is something every single one of us learned in grade school geometry.
The Cartesian coordinate system.
Right, the classic X, Y, and Z grid. Up, down, left, right, forward, backward.
Yeah, and if you look at the history of physics, I mean, from Isaac Newton to James Clerk Maxwell and even Minkowski's space-time diagram.
The ones that helped Einstein formulate relativity.
Exactly. This flat, infinite grid is basically the invisible scaffolding of everything.
But the author is basically saying this grid we've relied on for centuries is, well, it's a trap.
A massive one. And the reason is that a universal grid secretly smuggles in a massive assumption. It assumes a universal now.
A universal now, meaning what exactly?
It assumes that time equals zero, like the exact present moment is happening everywhere on that infinite grid simultaneously. The author views this God's eye view as a complete mathematical delusion.
Wait, let me just make sure I'm tracking this. The grid is a delusion because it assumes I can know what's happening at, say, coordinate point A and coordinate point Z at the exact same time.
Exactly. Right. I mean, in the realm of pure abstract math on a piece of paper, sure, you can draw a grid and say it all exists right now.
Right.
But in the actual physical world of electromagnetism, instantaneous, far-reaching action simply does not exist. Nothing happens everywhere all at once.
Because it takes time.
Yes. Information, whether that's light, sound, or a magnetic field, it takes physical time to travel through a medium.
Reading through the author's notes, this really clicked for me when I thought about it like a blueprint for a house.
Oh, that's a good way to look at it.
Yeah, like when you look down at a blueprint, you have that God's eye view. You assume you can magically see what's happening in the kitchen, the bedroom, and the garage at the exact same millisecond.
Right.
But if you're a physical human actually standing in the living room, you can't instantly know a glass just broke in the kitchen. You literally have to wait for the sound waves to travel down the hallway to hit your specific ears.
That is a brilliant way to put it. The blueprint is the mathematical delusion. Your physical position in the living room, waiting for the sound waves, is the physical reality.
Right.
By laying a perfect, instantaneous mathematical grid over the universe, physicists accidentally erased the reality of the delay. They completely ignored how long it takes for a signal to get from point A to point B.
Which brings up a huge problem. I mean, if human brains, and even the brains of legendary physicists, are constantly getting tricked by this assumption of a universal now, how does the universe actually deliver information to us?
It delivers it with a lag.
A lag.
Yeah, the author focuses intensely on this information delay, and here is where we get our first real paradigm shift. Spatial distance isn't really about physical space at all.
It's not.
No, distance is actually just a measure of pastness. It is purely a measure of how long it takes for information to reach what the author calls the observer's camera eye.
The camera eye. Okay, so that's the subjective observer. Like
Yeah.
you listening to this deep dive right now, you are the camera eye.
Exactly.
The author actually uses this great thunder and lightning analogy in the text to explain this lag. Imagine an event happens at a specific location. Let's call it coordinate x equals 1. A massive lightning strike. Now, the visual light of that lightning arrives to your camera eye in, say, 1 second. But the thunder, the rumbling sound of that exact same physical event, arrives 1,000,000 seconds later.
And that is the crux of it right there. It's the exact same physical event.
Yeah.
But it has totally different arrival times for the observer standing at the center.
Yeah.
The universe doesn't deliver a single clean now. It delivers fragmented, delayed information based on the medium it's traveling through and the ultimate speed limit of that medium.
That fragmented delivery is what the author calls mixed information right there.
Yes.
There's a Wimbledon umpire analogy in the text that I thought perfectly illustrated how messy this actually gets.
Let's talk about the tennis match because
Yeah.
it's so helpful. Imagine you have an umpire sitting high up in center court at Wimbledon. Player 1 is on one side of the net, player 2 is on the other.
Right.
Now, let's say both players get frustrated and shout at the exact same physical moment.
Time equals 0.
Right. But the umpire does not hear them at time equals 0. Depending on the slight differences in physical distance to the umpire's chair and even environmental factors, like, say, a strong wind acting as a shift in the air medium, the umpire might hear player 1's shout at time equals 6 and player 2's shout at time equals 9.
So the umpire is sitting there, and their subjective reality is that player 1 shouted first. But the objective reality is that they shouted together.
Exactly. The umpire receives mixed information. It's a tangled mess. It's this combination of where the sound started its spatial coordinates and when it started its temporal coordinates.
Wow.
So the umpire's brain has to unconsciously reverse engineer the event. They have to factor in the distance and the wind to untangle the signals and realize, oh, I heard them at different times, but they actually shouted simultaneously.
Okay, so if mixed information is constantly forcing observers to reverse engineer reality like this, how did the early pioneers of physics even attempt to measure this stuff without getting completely fooled? Didn't they build actual machines to test this?
They did. And that leads us directly to the title of the blog post we're analyzing, 5 atoms.
Yes, I was looking at this title going, like, what do 5 atoms have to do with Einstein's slacking off? Break this down for me, because this seems to be where the author thinks classical physics went completely off the rails.
To understand the 5 atoms, we really have to look back at the famous Michelson-Morley interferometer experiment from the late 19th century.
Right. Big moment in physics.
It's huge. This was a massive critical test where scientists were trying to measure the speed of light through what they thought was the ether of space, and the actual physical machine they built was this bulky, solid disk. It was, maybe 20 units wide, made of heavy stone and metal arms holding mirrors, and they rotated it through space.
But the author of this post absolutely despises the concept of that bulky machine.
Passionately, because a bulky, solid machine brings back the blueprint delusion.
Ah, right.
When you have a massive physical object, your brain naturally assumes that the mirror on the far left arm and the mirror on the far right arm both exist simultaneously in your current present moment.
Right, because they are attached to the same rock. You think they're both right there?
Exactly. But the author says, no, you have to strip the entire machine down to just 5 distinct local points, 5 atoms.
Okay.
You have 1 atom dead in the center. That is our camera eye, the observer at coordinates 0, 0. Then you have 2 atoms out on the x-axis and 2 atoms out on the axis. So they form a giant cross shape in space.
Okay, I see where this is going. By deleting the solid arms of the machine from our minds, we stop hallucinating that the distant ends of the machine exist in our present moment.
Yes.
We are physically forced to rely only on the arriving information. We can only know those outer atoms exist when the light bouncing off them actually arrives at the center atom.
Precisely. Now imagine this cross shape of 5 atoms is hurtling through space at high speed. The author points out that when the whole system moves, the light bouncing back from the outer edges takes different amounts of time to reach the center atom.
Why? Because the center is moving?
Right. The center atom is literally moving toward some of the light beams, which shortens the trip, and it's moving away from others, which lengthens the trip.
This is where the math gets tricky and where Einstein and Lorentz stepped in, right?
Yeah.
Because if you're listening to this and your head is spinning, trying to visualize moving atoms and light speeds, stick with us, because the way classical physics tried to solve this is wild.
It is so wild. So classic relativity relies on a fundamental rule. The speed of light must remain perfectly constant for all observers. Period.
Okay, but if speed equals distance divided by time?
Exactly. Speed equals distance divided by time. If the speed of light cannot change, but the time it takes for the light to reach the moving center atom does change because of the movement. How do you keep the equation balanced?
The only way to keep the math balanced is if the distance changes.
Yes. Einstein and Lorentz concluded that the actual physical space, the arms of the machine itself, must literally shrink in the direction of movement.
Wow.
That is what we call Lorentz contraction. The universe physically squishes to make sure the speed of light stays constant.
But our blog author calls total BS on this. They vehemently argue that the physical universe does not shrink.
The author claims Lorentz contraction is a massive optical illusion.
Yeah, and the author uses a fantastic comparison here. They compare Lorentz contraction to a trompe-l'oeil.
Right, the painting technique.
Yeah, it's a French term for a deceptive painting. Imagine a Renaissance painter using clever lines of perspective to make a totally flat 2D canvas look like a deep 3D hallway.
Oh, yeah.
The canvas didn't physically grow a hallway, right? It's just a visual trick on your eyes. The author says Lorentz contraction is the exact same thing. The moving object doesn't physically shrink in reality. We simply mistook a delay in arriving information for a physical shrinking of space.
And to really drive home how this information physically moves and causes this delay, the author swaps out abstract light beams for a supply chain metaphor.
Yeah.
It's quirky, but it works perfectly. They talk about magnets and trucks.
The magnet in the truck. I love this part. Instead of imagining invisible, static lines of magnetic force just sitting there in space like a grid, the author says to imagine a factory.
Yeah, okay.
The factory is the north pole of a magnet. This factory manufactures magnetic goods and sends them in physical trucks out to a market, which is the South Pole.
And crucially, it takes time for the truck to drive from the factory to the market.
Right.
The medium of space isn't empty, it's a highway.
Right. The market puts in a request like, hey, we need magnetic goods, and the factory dispatches the truck. But if the market physically moves its location while the truck is already en route on the highway, the truck has to adjust its path.
Because the information of the goods is physically moving through the medium. It is never instantaneous.
So this leaves us with a massive cliffhanger. If classical math fixed the speed of light problem by physically shrinking the universe, and our author says that is a complete illusion, how do we observe the universe correctly?
How do we map this delay without breaking the geometry of reality, right?
Exactly. And I have to say, my absolute favorite part of this entire deep dive is how the author chooses to solve this massive observer problem. They don't just throw another complex calculus equation at us.
No, we don't.
They bring in 3 legendary Chinese military strategists from over 2,000 years ago to personify the ideal observation system.
It is a totally unexpected, brilliant framing device. The author uses Hanxin, Xiaohe, and Liu Bang to represent 3 distinct layers of observation needed to understand the universe.
So let's start with the guy in the trenches, Han Xin.
Right. Hanjin represents the subjective camera eye. He is the local observer, sitting right in the dead center of the action, receiving all that raw, messy, mixed information we talked about earlier. To modernize the metaphor, the author says to imagine Hanjin is a pilot sitting in the cockpit of an F-35 fighter jet.
Right. He's flying at max speed, looking at control panel A on his left and control panel B on his right.
Because the jet is moving incredibly fast, the light leaving panel A and the light leaving panel B are actually arriving at Hanjin's eyes from slightly different moments in the past, depending on his speed and direction.
Yeah.
So to Hanjin, his reality is totally skewed by his own motion. He is experiencing the lag firsthand.
He's getting the mixed information, just like the Wimbledon umpire. He's totally subjective. So he needs a spotter.
Right.
Enter our second strategist, Xiao He. Xiao, he is the meta-observer. He's the outside strategist. Zhao, he isn't sitting in the jet moving at max speed. He is standing on the ground, observing both Hanjin's eyes and the light leaving the panel simultaneously from a fixed objective distance.
He's looking at the whole picture.
Exactly. Xiao. His entire job is to untangle the mixed signals. He calculates the lag that Hanjin is experiencing.
But, and this is key, having a pilot and a spotter isn't enough. You need an environment for them to exist in. You need a set of physical laws.
Ah.
That is our third figure, Liu Bang. Liu Bang is the absolute system. He represents the ultimate mathematical framework, the true geometric reality that allows us to view Hanjin's subjective delayed experience. And Zhao, he's objective untangling all under one unified system.
So Liu Bang is basically the ultimate rulebook of the universe.
Exactly. Liu Bang's geometry ensures that the subjective lag and the objective reality map perfectly onto each other without ever having to pretend that the fighter jet physically shrank.
And what exactly is the shape of Liu Bang's ultimate geometric system? Like, how does he map this universe? Because as we established way back with the grade school chalkboard, it's not a flat Cartesian grid.
No, it is absolutely not a grid. The grand reveal of the author's solution is that the universe is a sphere, specifically the time sphere, or as it's sometimes translated in the text, the time cylinder.
Okay, my brain is ready. Paint this picture for me. How does the time sphere actually work?
This is where the author completely remaps reality. Instead of an XYZ grid where every point is happening now, the observer, your camera eye, is placed at the dead center of infinite concentric spheres.
Concentric spheres.
Yeah, think of it like the layers of a jawbreaker or an onion, just expanding infinitely outward in every direction.
Okay, so I'm in the center of the onion.
Now here's the genius part. The distance from you to the edge of the first sphere, the radii isn't measured in miles or kilometers. The radius is literally time.
Whoa, wait. The physical distance is time?
Yes, a sphere with a radius of 1 represents everywhere in the entire universe where light left exactly 1 second ago. A sphere with a radius of 2 represents the exact boundary of 2 seconds ago.
Okay, let me just synthesize this, because this is the massive aha moment. By making the spatial axis, like how far away something physically is, and the time axis, how long ago it happened, the exact same thing. Right. By making them both just the radius of the sphere, you instantly solve the mixed information problem.
The delay is perfectly elegantly built into the geometry itself.
You don't need to shrink physical objects using Lorentz contraction to make the math work. The spatial depth of the universe is literally just a physical measurement of pastness.
Yes.
You aren't looking across space, you are looking down into time. Every physical step away from you is a step backward on the clock.
It completely eliminates the need for illusions. I mean, the flat Cartesian grid forces you to invent crazy tricks like shrinking space to account for the speed of light. But the time sphere accepts the speed of light as the literal architect of the shape of space itself.
It completely breaks your brain in the best way possible. To recap the journey we've been on today, the core takeaway from this incredibly dense, brilliantly eccentric blog post is realizing that our typical, everyday assumption about space, that things across the room or across the globe exist right now, simultaneously with us, is just a flawed shortcut our brains take.
It's the blueprint delusion we started with.
Right. True physics, according to this author, requires viewing the universe purely from the camera eye, where distance isn't really distance at all. It is purely a measure of how far into the past you're looking. And all of that messy, delayed information maps perfectly onto the concentric layers of your own personal time sphere.
Which brings us to a final thought I want to leave you with today, and it's a thought that builds on everything we've just unpacked. I want you to look around your immediate surroundings again.
Yeah, look at the screen you're listening on, or the window, or the person sitting across the room.
If every single thing you see around you is fundamentally arriving to your camera eye from a slightly different moment in the past, does a shared present moment actually exist anywhere outside of your own mind?
Oh, man.
Or are you, right now, forever floating perfectly and completely alone in the exact dead center of your own private and escapable time sphere?
That is a haunting, beautiful, and slightly terrifying thought to end on. You are the literal center of your own history. Thank you so much for joining us on this deep dive into the 5 atoms in the time sphere. We hope you look at the world around you a little differently today. See you next time.